Alright, so we have another Atwood machine problem. This is a simplified Atwood machine because there is no pulley, but it really does not change anything at all. So I think the really important part about this question is that we are limited to expressing every answer algebraically using only M, H, and G. Okay, we are told the rope attached to part A on the top part of the table has a length of 3H. The rope attached to block B is 1H, and block B is also height H above the ground. So, what is the acceleration going to be on block B as it descends? Okay, so since we don't have something like a pulley, I think your logic would tell you that this is going to accelerate downwards and this is going to accelerate to the right. Okay, we're told that it is a smooth tabletop. Okay, this is a key word that it means hint, hint, ignore friction. Okay, you can also think of it if there were friction, there's no way we could simplify things only in terms of M, H, and G. We would also have the coefficient there. Okay, so that's kind of another clue that friction is not present here. Okay, so A, we're looking for the acceleration. So the very first thing that we need to do is draw our free body diagrams. And for block A, we just have the normal force on block A, and then we have MAG, and then we have this tension force pulling it to the right. For block B, we have the tension, and we have MBG, and I believe they are of equal mass. Yes, they are of equal mass, so I really don't need the MA and the MB there. Okay, I thought that might help you. So this is for block A, this is block B. Alright, so right off the bat, if we look at this, we know that T minus mg is going to be equal to minus ma. I'm going to rewrite that. Okay, so we can write tension here is going to be equal to mg minus ma. Okay, so let me improve this. This should be shorter. Okay, so the weight force is greater than. Alright. But on block A, the normal force and the weight force should be equal, so they should be equal lengths. So if we were to, you don't really need this equation, but the normal force minus mg is equal to 0. And then for the x, it's basically tension is equal to ma. So how we're going to solve for A? Well, I'm going to use this, plug that into there. So we have mg minus ma is equal to ma. And my A's are looking sloppy. Okay, so then mg is equal to 2 ma, there's mass on each side, so that cancels. So acceleration is equal to g over 2. That's the answer to part A. Okay, so block B is now going to fall, and it's going to hit the floor, and we're trying to determine what is the time that it takes block B to hit the floor. So we have these kinematics here, but we already know the value of A, and we know our vertical displacement. So if we go from the second kinematics equation, okay, so remember how it's xf is equal to xi, and I always subtract xi to get delta x. Well, in this case we're dealing with the vertical, so that delta y is just equal to h in this case. Okay, and then, well, what is the initial velocity? The initial velocity is 0. So our initial velocity is equal to 0. So the only part that we have left is 1/2, and then g. It's normally it's 1/2 a. Normally it's 1/2 a squared, at squared. Oh my gosh. Okay. So what we should do now is input our acceleration, which was g over 2. Okay. So we can continue to simplify. This is g over 4 t1 squared. So we're solving for t. So I'm going to move the g over 4 to the left-hand side. So I'm going to multiply by 4 over g. This gives me 4h over g is equal to t1 squared. So now I need to square root both sides. Okay. So that's our answer there. Okay, so this part C is just a conceptual question here. It says describe the motion of block A from t is equal to 0 to the time t1 that block B hits the floor. Well, I mean, we saw this from our free body diagram. It's going to accelerate to the right. Right? It is the weight of block B that is really causing it to accelerate, because that tension is then pulling on block A, and that's really all you need there. D, describe the motion of block A from the time that block B strikes the floor and the time that block A leaves the floor. Well, like I just said, it is block B that was pulling it to accelerate. So now that block B has hit the floor, there's no longer any tension. So that means there's no force pulling it to the right. So it's no acceleration, and it's going to move at a constant speed. So constant velocity. Okay, so both blocks are going to eventually hit the ground, right? So block B is going to hit the ground first at a time called t1, which we found what t1 is equal to, and block A is going to hit the ground sometime later. Okay, now we just discovered that when block B hits the ground, block A is going to move at a constant velocity. Okay, so it's going to have a constant horizontal velocity. Block B does not have a constant horizontal velocity. Okay, so really, we're going to have to go back to our kinematics here and remember this. So this velocity here is going to be constant right before block B hits the ground. Okay, so let's use a kinematic equation. Let's look at our initial velocity here. So this equation is going to be for before block B hits the ground. Okay. I'm going to call it V1. Okay. V1x, that's fine. Alright, and T1. So T1 is what we solved for earlier in this problem. Okay, so for block A, this is going to be 0. And we know the acceleration. The acceleration on block B is going to be the same that is on block B. So let's rearrange this. V1x is going to be equal to 0 minus acceleration is g over 2 my mistake, you guys. This is V1. It's going by memory. There we go. Alright, so this one is 0. This makes things much easier, actually. Okay, so we can basically cross that out because it's 0. So V1x, or our Vx, is just going to be A times T1, which A we found to be g over 2, and T1 we found earlier. So it's our acceleration g over 2 times T1, which we solved was 2 times square root of h over square root of g. So we can get rid of our 2's, and if we remember our powers, if this is g to the 1 power and this is g to the negative 1/2 power, in the top we're going to be left with square root of h times square root of g, or square root of hg. So that is the final velocity of it before it hits, before block B hits the floor. So in order to determine the displacement of block A, we just need to plug in that horizontal velocity and then times the time. So hg, and then we're going to multiply again by 2 over hg. Okay, so a lot of you might find this easier to kind of write everything out like this. I'll make a line here. So I could bring the 2 to the front. And then an h over g. Okay. So look, the g's will go away, and we get 2h. So this is our final answer. This is how far the displacement of block A will be when it leaves the table. And if you remember from the beginning of the question that the entire rope is 4H, so this is half of the value of the rope. So this is a great question, lots of algebra here, and lots of kinematics. So I hope this helped you, and take care.